All right, so we're going to do a quick little reminder video on how to use a protractor. Kids should come into grade 7 already knowing how to use a protractor, or at least having had an opportunity to use it a little bit. I just want to remind you, using this video, the proper way and some of the commonly see as mistakes that kids make using a protractor. So shouldn't take too long. Follow along, rewind at any point if you think you need to. But there's a few basics that we need to make sure we understand. A couple notice the crosshair point here. This is always the 0, where we line up the protractor with the point of the angle that we're trying to measure or create. You'll notice that there's 2 sets of measurement increments. There's some on the inside. There's some along the outside of the protractor as well, because it depends on whether you're measuring an angle starting from the right and heading left, or vice versa. And we'll talk about that when we do a few examples. 90 degrees is a very important number to remember, a right angle. And we also want to remember a few other basic terms for geometry: an acute angle, angles less than 90, and an obtuse angle, angles between 90 and 180 degrees. Those are going to be important for us to remember. So very basically, if I'm going to measure an angle, there's one right there. I want to be very careful that I put my protractor down and I put the crosshairs right at the vertex point of the angle, the point where the 2 lines meet. So I want to be very careful and accurate when I do that. A lot of times students are really lazy, don't pay attention, they rush too much, and the vertex is nowhere near the point of the angle. Okay. I also want to, once I've got that lined up, I want to make sure that the 0 line on the protractor is right over top of the actual line, or the ray of the angle. So I want to make sure that it's lined up nice and perfectly there. A lot of kids, again, don't pay attention. They get it lined up with the vertex there, but they don't really pay attention and notice that the 0 line is way off. Okay, we want to make sure the 0 line is lined up with one of the rays, or one of the lines of the angle that we're measuring. There we go, looks good. So now I want to know how many degrees from this line is it up to the other line that makes up the angle. So here we are, we're taking a look. It seems like it crosses right there. Problem is, kids always make this mistake in reading the protractor, because the other ray of the angle crosses through 2 numbers. It crosses through 50 and 130. A lot of the times they default and just look at the biggest number, or the number on the outside, and say it's 130. Other times they're not really sure why there are 2 numbers here and how to know what the angle measures. Okay, so 2 things you need to remember. First thing is, just by looking at this angle, I can tell it's acute. It's smaller than 90 degrees inside here. So that tells me that the measurement has to be smaller than 90. So it makes sense that the correct one to pick is the 50 degrees, because that is less than 90. 130 doesn't make sense. 130 is an obtuse angle. It would be more than 90, so that one doesn't make sense. Another way to make sure you're doing it right is when you follow the line that you have lined up with the 0 of the protractor, find the 0 on the line and use the measurements that are on the same side as the 0. The 0 is on the inside here, so I'm going to be using 10, 20, 30, 40, 50 degrees. I wouldn't start from 180 and measure to the line. I always want to start with 0. So this angle, it's acute, and it measures 50 degrees. Okay. Similarly, here's another one. I chose to show you this one because the angle is oriented differently. If I put my protractor down again and line it up nicely, the vertex right at the crosshair of the protractor, now I've got the 0 line lined up with one of the rays. Now that I'm using the 0 that's on the outside, Again, it's an acute angle, so I know it's got to be less than 90 degrees. So it doesn't make sense to use the numbers on the inside anyways, because they're all larger than 90. But again, here's the 0. So I'm going to use the increments going from that 0 up towards the other ray of the angle. Again, 50 degrees. So it's the same size angle as before. Acute angle, 50 degrees. But it's just situated differently. If I wanted to, I could line up the other ray with the 0. With the 0 line of the protractor. Boom. There we go. Crosshairs at the vertex. I've got one of the rays lined up to 0. Now I'm just going to measure it this way. There we are, 50 degrees. Same thing. So it's important to make sure that you're using the protractor and measuring accurately and not making some of those simple mistakes. A couple other examples just to show some obtuse angles. Here's one that's obtuse. I can tell that it's more than 90. 90 degrees would come straight up here. Plunk my protractor down, line it up. Here we go. Here's the 0, so I'm going to use the increments starting from 0. So the outside ones, all the way around. Makes sense that I'm up into the 120s, 130s. Because it's obtuse, and it wouldn't make sense for it to be between 50 and 60. So we're going to 120. We're more than 120, but not quite 130. So I want to check, and kids often make a mistake when the angle is between two marked numbers on the protractor. They'll take a look at this and say it's 130, 1, 2, 3, 4. They'll say it's 134, but they don't notice and don't logically think that this angle falls in between 120 and 130, so it has to be between there somewhere. So here's 120, here's 125, one more 126. It looks like it's between 126 and 127. Okay, we're almost right at 127. So when it's an obtuse angle, 127 degrees. Let's try one more. Here we go. This is acute. I can tell it's acute because it's smaller than 90. So when I line up my protractor, again, I notice it's not measuring right on a numbered increment. So I want to pay attention that it's in between 70 and 80. So it can't be more than 80. It's not 85. It's between 70 and 80. So looks like we're 75, 76 degrees. A few straightforward examples, but some things that you really need to be aware of, be good at, and make sure that you're accurately measuring your angles with protractors. It's important for this unit. It's important to know how to do that in grade 7 and beyond. Hopefully you're going to brush up with those. Make yourself some angles. Just randomly put down two lines that connect and drop a protractor on and measure them.